everyone, my name is Elizabeth Phillips, and today we're going to be talking about geometric figures. So first off, we're going to start with angle relationships, and for question 1, we're going to figure out what the degree of each angle is based on its relationship on the figure. So I'm going to go ahead and get my screen right. There we go. And we'll start out with orange. Now when we look at our figure right here, first off, we need to understand that there are corresponding angles and supplementary angles in this figure that help us figure out what the degree of each angle is. So for complementary angles, any angle, and we'll use this as an example right here. These two angles right here, 2 and 63, are opposite of each other on two lines. Because it's only two lines and they intersect at that one point, they're going to be the same degree on both sides. So 2 would be 63 degrees, similar to the angle right across from it. As far as complementary angles go, it's really just angles that complement each other based off of where they are on a figure. Next, we're going to talk about supplementary angles. And supplementary angles, when added together, are going to make up 180 degrees. So we'll use this figure right here as an example. We have 6 and 61. We know that this angle right here is 61, and together they should make 180 degrees. So 6 should be 180 minus 61, which is 119 degrees. Now, if we really wanted to, what we could do is we could go through and just look at complementary, supplementary, and kind of figure out what degree each angle is supposed to be. So again, with this figure right here, we know that this angle is 61, which means the one right across from it is complementary to it and should be 61 degrees as well. It's the same thing going across for angle 6 and angle 10. They're complementary to each other, so angle 10 should be 119 degrees. Now what we want to do, and this is a simple thing, if you'll notice the triangle at the center of the figure right here, any triangle that you have is going to equal 180 degrees total. We already know 2 of the 3 angles here, 63 and 61, so we can go ahead and add those together, and we're going to go ahead and get 124. Now what we want to do to find that missing angle is we're going to do 180 minus 124, and we should get 56, which means that angle 7 is going to be 56. And I'm going to clean up a little bit right here. Angle 7 will be 56 degrees. Now complementary to that, we have angle 12. That will be the same measurement. And then directly next to it, we have angle 8, and if you'll notice, 7 and 8 make a supplementary figure. So what we're going to do, we know they equal 180 together. We're going to subtract 56 from 180, and we should get 124, which means angle 8 will be 124. Now again, angle 8 and 11 are complementary to each other, so 11 will be 124 degrees. And now we just need to solve for 1, 3, 4, and 5. Now the best way that we can solve for this, if you'll notice, and we'll get a different color for this so that we can kind of see what I'm talking about. These two lines right here going straight across are actually perpendicular to each other. Now when a line goes through two perpendicular lines, let me get a new color, this angle right here and this angle right here will be the same degree, and this angle right here and this angle right here will be the same as well. So given that information, we can easily determine that angle 4 will be equivalent to angle 9. So angle 4 will be 61 degrees. And complementary to that, we have angle 3, which will be 61 degrees as well. Now we need to solve for 1 and 5. If you'll notice, we have a straight line going across right here. That whole line is going to make 180 degrees altogether based off of the 3 angles. And you can add up the bottom or the top. I'm going to go ahead and do the top. They're pretty much the same thing, same numbers. You're going to do 63 plus 61, which gives you 124. Well, that sounds similar. We're going to go ahead and just do 180 minus 124. And we'll notice that angles 1 and 5 are going to be 56 degrees. And the funny thing about that is that this angle would then be similar to that angle right there, and that angle as well. And based off of this information, we now have the degree for each angle that we are given. Now for question number 2, we're going to talk about angle measurements and shapes. We're going to start out with this triangle right here. Again, remember what I had said earlier. Any triangle you have is going to be equivalent to 180 degrees. Which means this angle right here, this one right here, and this one right here of our overall triangle should be 180 altogether. So we're going to do 74 plus 26, which will give us 100, and we're just going to subtract that from 180, which means our angle 1 should be 80 degrees. Well, now that we know that, we can take a look at our triangle. We'll notice that these two lines right here are going to be parallel, which means that 1 and 5 will be complementary since they are directly across from each other, making 5 80 degrees. Do a little clean up. 5 will be 80 degrees. Now another funny thing, since we have these two lines right here as well, we can determine that 2 plus 5 is going to equal 180, because this angle right here and this angle right here, when two lines are parallel, are going to make 180 degrees for a straight line. So we're going to do 100 minus 80, which will give us 100, and since 7 is complementary to that, we'll go ahead and do 100 for that one as well. Well, now that we know what our 7 is, we can do the same thing right here with 7 and 8, which honestly 8 and 5 are complementary as well, meaning that 8 will be 80 degrees. And now we can solve for the small triangle right here at the bottom right hand side of our figure. So we're going to do 80 plus 26, which will give us 106, and then we'll subtract that from 180. So 180 minus 126 will give us 54, meaning the angle 6 is going to be 54 degrees. And then what we can do, since we have our 54 and we have a straight line, have a straight line going down right here, we know that 6, 5, and 4 should all add up to 180. So we'll do 80 plus 54. We've got 134. Now we're going to do 180 minus 134. 180 minus 134. And we should have 46. So angle 4 is going to be 46 degrees. Next, we can solve for our small triangle up near the top of the figure. We can do 74 plus 46, which will give us 120, and then all we need to do with that is subtract it from 180, which will give us 60. So angle 3 will be 60 degrees. So next we're going to talk about finding measurements in a concave polygon. And we're going to start out with this figure right here. Typically what you'll want to do is find the number of sides or angles on the figure to start out. So we'll notice we have one, might help if I have my screen right up, just so we can get some visuals. We have 1, 2, 3, 4, 5, 6, 7, 8 points, 8 sides. We're going to go ahead and incorporate or use this equation to help us kind of solve for the degree of each angle. It's 180 times n minus 2, with n being the number of sides or angles that we count in our figure. So given that information, we can automatically make the equation 180 times n, which was 8, minus 2. 8 minus 2 is going to be 6, and then we just do 180 times 6, which will give us 1080. So our figure should have 1080 altogether when we add up all the measurements. Well, now that we know that that has 1080, what we're going to do is we're going to add up all of our y's in the figure. If you'll notice, we have 1, 2, 3 sevens. So 3 times 7y plus, or well, 7 I should say. We have 3 threes, 3 times 3, and we have 2 12s. So 2 times 12. Now what we want to do is we want to figure out what all that adds up to, which is going to be 54. So this is where the easy stuff comes in. We have our total, we have how many of each angle we have, or of each y we have. So we're going to do 1080 divided by 54, 0 divided by 54, which will give us 20. So y is going to be 20. So now, in order to solve for each angle, and we're going to erase this since we already have that information. Now, since we have our y, we can find the degree or measurement for each angle. Starting out, we have our 7y, which will be 7 times 20, or 140, meaning that each angle that has 7y will be 140. 140. Then we'll look at our 3y, which will be 3 times 20, which will be 60. So each 3y will be 60 degrees. And then we look at our 12y, which is 12 times 20, which will be 240. So each 12 should be 240. And that will be the measurement for each angle that we have. Next up, we're going to find measures of interior, exterior, and central angles. So we have a model right here. We're going to do or approach this problem the same way that we did the last one. This right here is a nonagon, meaning that it's going to have 9 sides and 9 angles. And we can double check that with this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to incorporate the same equation into our question, which was 180 times n minus 2. Well, we know that our n is 9, so we're going to do 180 times 9 minus 2, or 180 times 7, which should give us 1,260. So each angle when added up, should equal 1,260. Now, we know that we have 9 sides, so we're going to do 1,260 divided by 9, meaning that each angle should be 140 degrees. We'll put a note up here. Each angle equals 140 degrees. So if each angle in our figure equals 140 degrees, or outer angles at least, we can easily determine that this question mark right here is going to be 140 degrees. Well, now that we know how much each angle is, we can assume that this one is 140 as well. And we can also assume that since we have our line here, that angle plus our unknown should be 180 altogether. So what we're going to do is we're going to do 180 minus 140 for our angle, meaning, which makes this, our unknown, 40 degrees. Next, what we're going to do, if you'll notice, this point right here is actually going to be the center of the circle. And given that it's split the way it is, we can assume that this is an isosceles circle, making each angle here half of what it originally was. So all we really need to do is 140 minus 2, making each of these bottom angles down here 70 degrees. So we're going to go ahead and put 70, 70, and now we need to find that unknown. Well, with any triangle, it's going to be 180 degrees altogether, so we're going to add our knowns. 70 plus 70, we get 140, so we're just going to do 180 minus 140, making this angle right here 40 degrees. Next, we're going to talk about tetrahedrons. For question 5, we're given a cube right here, and we're needing to find the tetrahedron DEGH. So what we're going to do is we're going to connect all of our points. We have D here. Whoops. Might help if I have my screen right up. We have D here. We have E here. G here. H here. So we should have a tetrahedron that goes through the side of each square over there, like that. And that's what our tetrahedron would look like. All you do is connect the points and eventually get a shape like that. And that's actually what a tetrahedron is meant to look like. Next, we're going to talk about Schlegel diagrams. On question 6, we're asked to draw a diagram for each of the following. We have a tetrahedron, an octahedron, and an icosahedron. Now we already know what our tetrahedron looks like, and I'll go ahead and draw up a simpler diagram. For our tetrahedron, we simply have a triangle right here, just trying to make it a little straight, and then it meets at one corner or one point like it did on our cube. Just like that. Now next up we have our octahedron. Given that it starts out with octa, we can assume that it will look like this. We're going to have our triangle like normal, and then it's going to break down into a bunch of smaller parts to where all the points are connected. And I apologize for my poor drawing skills. And there we go. That's what similar to what an octahedron would look like, just slightly messier. Next, we're going to draw an isosahedron. We know it starts out with isosa, so we can assume, and this is going to be a fun one, we can assume that it'll be similar but slightly more complicated than our other triangles. So we have our base. And our isosahedron. And again, I apologize for the poor drawing. You're welcome to look up exactly what it likes. I know mine is not the best example, but this, simply put, is what an isosahedron should look like. Alrighty, that is it for our questions. I hope y'all learned something, had a good time, and I will see you next time.